Good evening, guys. Myself, Balachandar. I work as an Android consultant at Babylon Health. I attended my first talk at first Learn Ride 5 years ago. So now I'm giving my first talk at Learn Ride, so I'm really happy. Thank you guys for attending. So let's get into the topic. So I'm going to talk about developing IntelliJ plugins, but of course there are so many other tools that you guys might be using in your company to impose a guideline or to make your life better. So there's so many other tools. Some of them are these are some of the tools like custom Gradle task, custom lint rules, detect rules, so many different scripts using so many different languages. But I guess IntelliJ plugins are one of the least used tools among developers to improve their productivity or to impose guidelines. Can I ask how many teams have their own IntelliJ plugin? They are from Babylon, so they don't count. That's good to know, but yeah, this talk is more about what we can achieve with IntelliJ plugins by developing your own plugin. Of course, it's not going to take a huge learning curve like RX Java. It's going to be a small learning curve, but give big benefit. As you guys know, Android Studio itself comes with a lot of pre-installed plugins. So if you install Android Studio and go to the plugin section, you may already see so many plugins installed. Google themselves provide a lot of functionalities via plugins. Take, for example, deep links. So you may see in Android Studio, if you go to the tools menu, there is an option to add deep links. So that whole functionality is developed as a plugin, and you can see it in the plugin section. And if you can disable those plugins if you don't use them, so that you get better performance in Android Studio. And there are also very good plugins available in the community. As you guys laugh, I can see that many people are aware of the Neon Cat plugin. Because of the build time, we beat the boredom using the Neon Cat plugin. I also have another interesting plugin that I personally like, which is a current activity finder. So what this plugin does, so if you have a connected device or emulator, and if you have your app opened on it, in a debuggable app, whichever activity is in foreground, this plugin opens that activity in Android Studio. So if you are in a new project, or if you are in a new code base that you are not aware of, so then you can use this plugin to quickly find which activity is currently on top of the screen. So it's very simple, but it's quite effective, right? It may take 1 day to develop, but it's quite effective. So I have this QR code in some of the slides. It's very small, I know it's hard to scan, but these QR codes are clickable. So I will share the presentation afterwards, so you guys can just click it, and it takes you to web pages where you can find more resources about specific slides. So this slide is about plugins, so this QR code will take you to somewhere where you can find more plugins. So we can categorize all the plugins into 4 types as per the IntelliJ docs. I'm not going to talk about the first 2 types because they take more time to develop and they require a lot of effort. So I'm going to focus on these 2 types of plugins, which take less time to develop, but they can provide more benefit. Depends on your use case. So you can come up with your use case if that requires a plugin. So we are going to learn the basic building blocks. This is going to be the small learning curve that you need to understand what you can do with plugins with a very, very small learning. So we're going to go through the building blocks. There are only just 5. Don't worry, there are not going to be more than that. So let's take a look at the structure of plugins. So for plugins, we use Gradle as the build system, Kotlin or Java as the programming language, and we can use IntelliJ IDEA Ultimate or free IntelliJ Community Edition to develop. So it already kind of feels familiar for Android developers. Are the mics working? So for Android developers, it might already feel familiar because it's the same tech stack that we use to develop Android apps. And let's take a look at the project structure. So there is a build.gradle file, so you guys know. And then the source includes Java or Kotlin source code. And then we have plugin.xml file. You can relate this to the Android manifest file. So this is where you declare the components that you use in your plugin, so it can be like different components. It's very similar to the Android manifest. And then we have the test source, so where you can write unit tests to test your plugin code. Okay, so the first building blocks in developing a plugin is components. So there are 3 different types of components. So the first type is application component, which is instantiated when you open Android Studio or IntelliJ. When the IDE starts, this application component is created. And then each application component, and then for each project that you open inside IntelliJ, you get a project component. And then for each module that you open inside a project, you get a module component. So you can relate this to lifecycle components. So if you want to do something when IntelliJ starts, then the right place to look for is application component. If you want to do something when you open a project, the right place to look for is project component. So it has the lifecycle callbacks where you can hook up and do different things. And then there is this application manager through which you can access these components from anywhere in the code. You are free to have your own architecture, and you can put these components inside. You can get the lifecycle callbacks, and you can do your stuff. Right. So if I just have like a parallel to Android world, you can connect application component to the Android application class, and then the project component can be related to the Android activity. So so there is one application for the whole app, and then we have multiple activities inside the app. So similar, we have multiple project components, and then inside the activity we can have multiple fragments. Similarly, we have like module components. So I'm just drawing like a parallel so that it's easy for Android developers to think about it. And the second building block is services. Similar to application component, we have 3 types of services in IntelliJ plugins. One is application service, the second one is project service, the third one is module service. They are basically singletons maintained by IntelliJ plugin system. So you need to declare the service in the plugin.xml file, and then you're free to use it anywhere. But IntelliJ will make sure that it doesn't matter how many times you call it, it will always provide the same singleton back to you. So you can see like the service manager.getService method returns your service. So it's like scoped singletons. If you draw parallel to the Android universe, it's basically singletons with different Dagger scopes. You can say app scope, a singleton with app scope is application service, a singleton with activity scope and fragment scope, and so on. And then the third building block is an action, which is my favorite building block because it requires very, very minimal effort, but it can be very beneficial based on your use case. Sometimes your use case can be just satisfied with an action, and it can. So I will tell you like how to declare an action and how to use an action. So if you draw parallel to the Android universe, it relates to Slices API, which came recently, or the broadcast. So that so if you declare an action, and if that action is performed by the user, the IntelliJ plugin system will give a callback to your class, so that you can do whatever you want. So the user clicks an item in the menu, and you want to do something, you can do it over there. So to register, to register an action, you need to declare the action inside the plugin.xml file, which is similar to the Android manifest file I just told. So if you see, you declare the ID class, the text will be the title of your action wherever IntelliJ wants to add, and then the description will be the text that is shown when you hover over that particular action. And then you need to specify where to add this action. So that's where we specify action group. The editor pop-up menu is the one that we show when you right click inside in the IntelliJ editor. If you open the IntelliJ editor, and if you open any class, and if you just put the cursor and right click, we are shown a default menu that's called the editor pop-up menu, and we say that the anchor has last. So so this particular action will be shown as the last item in the editor pop-up menu, and whenever the user pressed that particular item, we will get a callback to the class declared in the class parameter. So the class will look like this, very simple. So it has just 2 methods that we need to override, which is action performed or update. So inside action performed, we get the action event itself. So the action event provides the context for you. So the action event will contain who called it, or from where this particular event happened. So with that information, you can do a specific activity that you want to perform. And the update method is useful when you want to hide this particular action in some specific cases. Say that, for example, you want to hide this action for Kotlin files. You want to show it only for Java files, or you want to show it only for the XML files. You can do this logic inside update method so that it won't be shown in all the cases. And the fourth building block is persistence. Whether you are developing a small plugin or a big plugin, you might always want to store something, right? So that's why we have a properties component, which just stores a key value pair. It basically puts everything in an XML file that is accessible inside the .idea folder. So it's okay to put something that is not as sensitive, but if you want to store something like a username, password, or a token, we have another API called password safe API. So this is something you can explore to store how to store secure data. If I want to draw parallel to the Android universe, I guess you guys already know what it is. Can you take a guess? Yeah, of course, shared preferences. So it's very similar to shared preferences. And the last part is UI components. So now, say for example, you declared an action, and when the user triggers the action, you may want to get some user input. So to get the user input, you may want to create a dialog, or you may want to show some toast, or you may want to show a panel, and then ask the user to enter some text. For this stuff, you need to create the UI components. So for those who used Java mobile development, like earlier days before Android, they might know like Swing toolkits and this stuff. But for those who entered into programming like after Android, they may not be aware of Swing UI toolkit. It's not that easy like how we do things in Android. But recently, IntelliJ introduced a Kotlin DSL support for developing plugins. So as you can see in the snippet, we just declare a panel. Inside the panel, we just declare a row and a button, and we also get an action event. And in the action event, we open a browser page. It's just one line to open a web URL in your this line opens the URL in your default browser. So if your use case is something like opening a web page from IntelliJ, this is just one line. You can add an action, and then you can open the URL in your default browser. Okay. So we learned 5 building blocks for developing a plugin. So now I'm going to show some use cases, how we applied these in Babylon Health to develop some integrations. So I'm going to show 3 integrations that we did at Babylon Health. So the first integration is for the Android code templates. So how many developed their own code templates? Yeah, so you guys might know the pain. So you need to create the code templates and then put that in a specific directory inside the Android Studio instance. And then every time when you upgrade your Android Studio, this dialog pops up. It understands that this is something like not part of the Android Studio, so it wants to delete it. So you need to delete all your code templates to upgrade, and then you need to place the files again. So if you are working in a team and if you are sharing a lot of templates with all the developers, it's a pain to keep it consistent and provide like a newer updates to your code templates. Even though there is, so that's why we thought of like plugins can help us here. So our first integration is a code templates updater. So this is how it works. So we open Android Studio. We have a custom application component which is triggered as soon as you open Android Studio. So now our plugin goes and checks if the code templates are present inside your Android Studio instance. If it is present, it just allows the business to resume as usual. So it opens Android Studio and you continue to work. If it is not there, it's going to show a dialog saying, hey, you don't have the templates. Do you want to add it? If you say yes, it places the templates in the right directory and restarts Android Studio. So Android Studio indexes all your templates, and then when you see it, everything, you will see all the templates. And it also helps us, so that's the first use case we did. And the second use case is versioning our templates. So it's good that we have templates, but as we change our architecture and as we introduce more changes, the templates go out of date. And how to keep the templates up to date? So now our plugin has a versioning logic so that when we want to update our templates, we update our templates, we put them inside our plugin, and we release the new plugin version. So everybody updates to the new latest plugin, and when they restart Android Studio, they are prompted to update their templates, and the plugin deletes their old template version and then adds the new templates, restarts Android Studio. As we do this in the application component, it will be very quick. As soon as you open Android Studio, it will straight away show this dialog and will stop Android Studio from proceeding. So this will be very quick in updating templates. So this is how we manage our templates. And the second use case is adding a gutter icon for Testrail link. To give some context, we use Testrail as a test case management tool. Our QA adds all the test cases to Testrail, and then we automate them by writing espresso tests. And so we have an annotation which connects our Testrail test cases and the automation test, and the annotation contains the ID of the test case. So if someone wants to open this test case in Testrail, they need to copy the ID and open Testrail and search for it. So every time someone automates the test, they need to do this regularly, so it's kind of wasting time. So our plugin now checks for this annotation inside the current open file. If there is an annotation, it reads the ID, and then it adds the clickable gutter icon on the left hand side. Like the icon you see next to the number 32 is the icon added by the plugin. So if you click it, it opens the Testrail test case on your default browser. So it's quite simple. It may save like few seconds for someone whenever they use it. And the third integration we tried is adding a docs menu inside Android Studio. So as your project grows, you might have a lot of documentations, you might have a lot of help tutorials, but it's stored in GitHub, or some teams have their website, GitHub, but it's also useful to have them inside your Android Studio instance so that you don't need to switch the context. Android Studio is the tool that we mostly use like 60% of time, so you can just click the menu item and go through it. To create this kind of extra menu, it all can be done by declaring actions in the plugin.xml. You declare an action group, specify that you want to add it to the toolbar menu, and just handle the callback, and open the link using the browser util that I have shown previously. It's just very simple, and you can add your own menu item anywhere. So that's the third integration we did. So we have talked enough. I want to show some code for sure. So I picked the NeonCat source code to show you guys what it takes to build a plugin like NeonCat, right? So let's see the code. So I'm just stop sharing, and then I'm going to share my whole desktop. Right. So this is the source code for the NeonCat plugin. So it's very simple. It has okay, let's see the project structure. The project structure has source, main, Java. It has 3 Java classes. And then it has resources. The resources contains meta-inf, which contains the plugin.xml, which is similar to the Android manifest. Let's take a look. It has ID, name, vendor, which are mandatory fields. And then the description you have explaining the app, explaining the plugin, and then something about which version your plugin supports, and then you declare an application component. This is how you declare the application component. So they have just one application component in the NeonCat plugin. So I'm opening the application component, and the application component does just one thing. So it replaces the progress bar UI with a custom progress bar UI. So it does that in the application component. So it is done very early, as soon as you start your Android Studio. So after that, all the progress bars you see inside Android Studio will be the NeonCat progress bar. And then the NeonCat progress bar UI extends the basic progress bar UI, and then it does a lot of different logics to move the cat from left to right and right to left. So you can take a look at this. It doesn't need to be this complex. You can think about replacing other UI components as well. If it is a use case for yourself, for your company, you can do that. So let's see how. So now we know what's the plugin source code and all. So now you might think how do I test it? Do I need to create the plugin, open my Android Studio, install it, and then test it? Is it a very long cycle? So luckily, we don't need to do all that. So Sometimes you get the configuration window with the right actions over here, but if you don't get the right ones, like look for the Gradle tasks. That's what I would rely. Sometimes it messes up. So you look for the task called run IDE. So the run IDE task, I'm going to just run it. It will be fast because I ran it just before the task, so everything is up to date. It's going to be fast. So everything is up to date. So now it compiled the code, and then it started a sandbox version of IntelliJ. It installed your plugin and opened it for me. So so this instance of IntelliJ is a sandbox version which contains my plugin and some basic plugins. And the sandbox version is defined in the plugin.xml file or your build.gradle file. So I'm going to open it. So you see the neon cat progress bar, right? So it's that simple. So if you are developing a plugin to test Kotlin code, so you create a sample project with that exact set of Kotlin code, and then from the sandbox version you open that project to test whether your plugin works or not. So I'm going to make a minor change just to be sure that it really works. So I added a couple of Android mascot icons here. So I changed it. And the build time is much faster. So you guys no need to worry about long build times. It's like 10 seconds maybe. It opens the whole sandbox version of IntelliJ. So I open it. So you can see the neon cat is now replaced by the Android mascot. So this is IntelliJ Community Edition. Creating a new plugin project is straightforward. So you just go here, choose IntelliJ platform, and then add Kotlin support, and that's all. It will create a sample project without any Java or Kotlin code, but you get the idea. It got nothing much to explore. It has no test. It also interestingly has a MP3 file. I don't know whether the neon cat plugin plays some MP3 file. I'm not using it personally, so I don't know. So let's get back to the presentation. So we built a plugin. So we have our own plugin for the company now, imagine. But it's important to distribute that plugin very effectively to everyone so that all the Android developers are using the latest plugin all the time. So the first method, the crude method, is to share the zip file or the jar file of your plugin straight away to the developers, or to put it somewhere in GitHub and ask the developers to go and update it. It won't happen. So you can find the build directory after building the plugin, and then inside that you can see the plugin. So the second method is to publish that in IntelliJ plugin repo. So this plugin repo is public to everyone. So if you're building something for the whole Android community, then go here, publish the plugin. So neon cat progress bar is here, so that's why it's accessible to everyone. Straight away, if you install IntelliJ and search for it, you will find it because it's here and it's added by IntelliJ by default. And the third method is private repositories. So if you're developing something specifically for your company, you can create your own plugin repository. It's nothing but an XML file that is hosted somewhere. This XML file should contain all the details about your plugin, what version it is, so that IntelliJ smartly identifies that you have a new plugin version. So it will show the new plugin update dialog and everything. So this is it. This is a sample for our Babylon plugin, how we declared the different parameters. And then you need to go to plugin preferences, manage plugin repositories, and add it. So it's a one time for all the developers. Add the plugin XML, and then every time you have a new plugin update, just go there, update the XML file, and then IntelliJ will automatically show, hey, there is a new plugin available for your private plugin. And then you just click and update it. It's a regular process. So I have a bonus slide, which is developer mode. IntelliJ also has a developer mode. Just like Android Studio, you need to do a bit of extra work to enable it. So the way to enable it is to go to Help window and select Edit Custom Properties, and then add this flag manually, idea.is.internal equal to true. So once you enable it and restart, you get an extra item inside the Tools menu. Inside Tools menu, now you see like internal actions. It won't be visible by default. You need to enable the developer mode. And the developer mode has so many different methods. I haven't explored all of them, but I found one very useful, which is UI inspector. I'll show you like how it works. So say for example you want to so there is an event log button over here. So I want to add something similar to this inside my plugin. So I want to know like what class it is. So I do like Control Alt and tap it, and it will open the whole hierarchy, and then it will specify like which button it is. So it's stripe button, and it will also show like all the different properties of this particular UI item. So it's quite useful if you want to implement something very similar to what you see in the screen. I put some references, and I also have different links inside the slides. Now it's time for you guys to go and think about the use cases you have for plugins. So just consider plugin as another tool to solve your problems. It's not the tool, it's a tool to solve your problems. Thank you guys. Thank you for your time.